Today's lesson is about solving equations with variables on both sides. Your learning target says, I can determine a process for solving equations with variables on both sides and use it to find the correct solutions to the problems. We are going to start with numbers in isolation. We'll eventually get into some story problems, but I want you to think about skills that we've learned earlier in this unit. Remember, we've talked about how you had to learn the distribution property before you could simplify, and you had to learn to simplify before you could solve. Well, all of those skills are going to come into play in this unit, this lesson. So let's look, for example, on the left-hand side of this equation. I always want to simplify my equation down before I attempt to solve it. So I'm going to alter this a little bit. Instead of 3x plus a negative 1x on the left, I'm just going to call that 2x's on the left and then x plus 4 on the right. And now that it's in simplest form, I'm going to attempt to solve this. Now the problem is over here on this side. I want to separate my variables and my constants. I want all the variables on one side of my equation and all the constants on the other. And since I have variables on the left, maybe I want to move this x that's on the right. So to move that, I could subtract x, but if I do it to one side, I have to do it to the other. That removes the x from the right-hand side, and I'm left with a 4 over there. And 2 x's minus a single x is 1x. I had an equation with variables on both sides. I separated my constants from my variables, and I solved, and I believe x equals 4. But just to be sure, remember you can plug a 4 in everywhere you see an x, and let's just see if it actually works. So we have 12 plus negative 4 on the left side, and we have 4 plus 4 is 8 on the other. That works out. X equals 4 is my solution. Again, thinking of the skills that we've had so far this unit, when you see this, you should be thinking, I should distribute that. So let's simplify before we try and solve. So in my first set of parentheses, I would have 2 times negative 3x, which is a negative 6x. And in my second set of parentheses, I'd have 2 times 1, or 2. And then the other side looks just fine to me. Now, if you notice, I have variables on both sides, and I have constants on both sides. So when that's the case, it really doesn't matter where you decide that you want to start. I will probably always start with my variables. And thinking ahead, I don't really like negative numbers all that much. So although it doesn't matter where I start, I'm going to add 6 x's to both sides, because if you watch, let's see what happens. This disappears. That leaves 2 on one side. Negative 2 x's plus 6 x's gives me 4 x's on this side and a 10. Not only did I eliminate the x's from the left side, I also got rid of my negatives. Now, you didn't have to start there. That was my personal choice. So now, on the right-hand side, I have to separate those. And because I have constants on the left, let's go ahead and remove that constant. A positive 10 and a negative 10 will cancel. That leaves 4 x's on the right. And although I tried really hard, sometimes negatives cannot be eliminated totally, because 2 minus 10 is negative 8. To isolate my variable, now I have to divide both sides by 4. And I'm going to have negative 2 on the left and x on the right. I feel that is my solution. But to check it, I'd put a -2 right here, and I'd put a -2 right here, and let's just see what happens. So -3 times -2 inside the parentheses is 6. Still inside the parentheses, 6 plus 1 is 7, and 7 times 2, I have 14 on the left. And then I had -2 times -2 on the right is +4. 4 plus 10 is 14. That worked out. I have the correct solution. So now let's start putting our algebra into worded problems and seeing what we can do with that. So we have 5 added to twice Ari's age. So it looks like we need to take 2 Ari's and add 5. That's on one side. Is the same as is an equal sign. 2 less than 3 times his age. So 3 Ari's minus 2. All right, so I've got my equation here. I have both variables and constants on both sides, so it doesn't really matter where I start. I'm going to go ahead and have you start without me. See if you can solve this and come back when you're ready to check how I did it. All right, I'm going to choose to start with my variables, but it doesn't matter. You can start anywhere. I'm going to take 2 A's off of both sides. And when I do that, I'm left with a 5 on one side. 3 A's minus 2 A's is an A on the left minus 2. Okay, to isolate my variable, I'm going to add 2 to both sides. I think Ari is 7. So if we took 5 plus twice Ari's age, which would be 14, we'd get 19. And if we took 2 less than 3 times his age, which would be 21 minus 2, we'd still get 19. We have the right answer. This time I want you to try and set up the equation and solve it. So pause me while you work and then come back when you're ready to check how I did it. All right, so here's what I'm thinking. 3 times the perimeter. 3 times the perimeter is the same as, is an equal sign. 75 decreased by twice the perimeter. 75 decreased by 2 perimeters. Okay. I only have a variable on the left, so that means that's what I need to move away from the right. Remember our first example? I said if you have both on one side, then those are the things you need to separate. So if I were to add 2 perimeters to both sides, notice what happens. That goes away, and then I've separated. I have 75 on one side and 5 p's on the other, which is what I want. I want my variables and my constants to be separated from each other. All right, so to solve this one, let me change colors. I would divide both sides by 5, and that leaves the perimeter is 15 of whatever our unit happens to be. So let's check that. 3 times the perimeter, well, that would be 45, is the same as 75 minus twice, which is also 45. We have the right answer. Here's a problem that's a little bit more of a real world situation. So I want you to set up your equation and solve it. Come back to me when you are ready to check how I did it. All right, so here's what I'm thinking. To repair body damage on a car, we have auto body. They're going to charge $125 and $18 per hour. Car care is going to charge $200 and $12 per hour. And I want to know when they will cost the same, so that's an equal sign. So when you have both variables and constants on both sides of your equation, it does not matter where you start. Just pick something and go there. I'm going to go ahead and get rid of my variables because I generally start there. So I'm going to go over here this time. I'm going to take 12 h's off of both sides for no reason other than I don't like negative numbers. So notice this cancels. I'm left with 125 on one side and 6 h's, and on the other side I have 200. Okay, I have to change my color. Let's go green. All right, so now on the left-hand side I have both variables and constants. I have to separate them. And because I have constants on the right side, that's what I'm moving. So I am taking 125 off of both sides. I'm going to have to come up here where you can see better. All right, I have 6 h's on one side, and 200 minus 125 is 75 on the other. Okay, we're down to one step. To isolate my variable, I would divide both sides by 6, and I would get 12 and 5/10 hours. If both of those shops worked on my car for 12 and a half hours, it would cost the same amount. This is your last problem. I would like you to write and solve an equation. You're going to pause me while you work and come back when you're ready for checking. All right, so here's what I see. I see Christine bought a new snowboard for $136.50, but she still needs to rent boots. So we're going to add $8.50 for every day she's on her trip. Or she has a different option. She could rent everything for $18.25 per day. And we want to know, when would one option be as much as the other option? So I'm going to put in an equal sign. Okay, so I have both a variable and a constant on the left. Those have to be separated. So to decide which one I'm moving, I look, what do I have on the right? Well, those are my variables. So I'm going to move my variable off of the left. I'm going to subtract 850D from both sides. When I did that, notice I had my constants on the right, and I think I have 975, but I'm just checking. I have 975D on the right, so I have separated my constants and my variables. And now I have a one-step equation. I'm going to divide both sides by 975. When I do that, I have D isolated, and $136.50 divided by 975 would give me 14. So in 14 days, it won't matter which option she uses. She will pay the same amount of money.